PowerPoint show. My name is Emmanuel Julian. I'm going to take you through a few slides, which is going to be on the nature and reflection of light. But in this particular slides, I'm going to discuss on the aspect of reflection of light at plane surfaces. You have always imagined how you be standing in front of the mirror as you smile and you move your hand. The image in the mirror also moves the same way. It's almost like the image in the mirror is perfect copy of you, but reversed. This happens simply because of a process called the reflection. But then you want to ask yourself a key question. What is a reflection? Basically, the image you see in you is as a result of bouncing back of light rays when they hit a shiny or a polished surface. So in this case, you realize that the key question we're asking here, what is reflection? Reflection is basically the bouncing back of light rays when they meet a surface. Now, there is also one thing you need to note when you are discussing about reflection. Basically occurs when light meets a smooth surface, such as a mirror, water, or a shiny metal. Therefore, light does not pass through the surface, but instead it returns back into the same medium, usually air. However, you also need to note that an object with a shiny polished surface reflects more light compared to objects with dull or unpolished surfaces. And this basically explains to you why plane mirrors have a shiny surface and it is designed to reflect as much light as possible. But then during the reflection aspect, it occurs in two forms. So in our next aspect, we're going to basically talk about the types of reflection. There are basically two types. We have the regular reflection, sometimes can be called the specular reflection. And then there is irregular reflection or diffuse reflection. Now, I want to go ahead and look at what each of these types of reflection is all about. And we shall begin with the first one, and that is the regular reflection. What is it all about? And in this one, basically this one occurs when a parallel beam of light falls on a smooth surface and the reflected beam comes off as a parallel beam as well. And if you look at in our areas where it can occur in surfaces like plane mirrors or polished surfaces. Those are surfaces which are smooth, and those are the ones which are responsible for bringing the aspect of regular reflection. And we also want to look at illustration of the regular reflection. As you see, there is a smooth surface there. A parallel beam of light comes in and hits the surface, and it is reflected as a parallel beam as well. So that is a representation of regular reflection. But then also you need to know that when light reflects off an object and travels to our eyes, we perceive the object as an image. Like in the beginning, I told you that when light falls on a plane mirror and you're standing in front of that plane mirror, you can be able to see the copy of you. And it means that light has fallen onto that plane mirror and you're able to see yourself. So that is basically what we mean by the regular reflection. How about the other one, which is the irregular or the diffuse reflection? What is it all about? It is opposite of the regular. This one occurs when a parallel beam of light falls on a rough surface and is reflected in different directions. So that is basically what this one is. And if you look at the illustration here, this is a parallel beam of light which falls onto the surface. But upon reaching the surface, take for example a rough wall, the rays tend to be reflected in different directions. In brief, they are not parallel. As they are reflected. So that is basically what irregular reflection is all about. But you also need to know that however much it doesn't come as a parallel beam, it has also gotten some advantage of it. If you look at, take for example, in our rooms where we rest as we were inside the houses, sunlight does not reach directly into them. But we can see things clearly in the rooms due to the regular reflections. Most especially the light falls through the windows, through the door, through the ventilators. And yes, it comes as a beam, but when it falls on the surface, take for example, a chair, the carpet, it tends to be reflected in an irregular way. And that's how we end up seeing light inside the room. So that is basically the two types of reflection. However, in this video, I'm also going to take you through the guided explanation of the different types of reflection. We're going to differentiate while seeing some of the surfaces here. So in me here, we want to talk about how do we differentiate the two types. We have surfaces here. If you imagine, look at the plane mirror there, and then there is also another surface here which is rough. So we want to discuss how these surfaces bring about the aspect of reflection. And if you look at the two surfaces, this other one is the regular type, and then you ask, but do they reflect light? So we want to discuss about these two. There are two surfaces, the polished surfaces and then the rough surfaces. This is water, this is a plane mirror, this one's a wall, this one is a piece of wood. So the first bunch is the regular reflection occurs in them, and then the other one, diffuse reflection occurs in them. So we need to look at take a closer look at these two surfaces. And we're going to begin with the first one. When a parallel beam of light, as you see there, falls on a surface, a polished surface, okay, the reflection takes place and it is reflected off the surface as a parallel beam, and that is what we call the regular reflection. It occurs, as I told you, it occurs in polished surfaces, smooth surfaces, or shiny surfaces. Take for example, if a parallel beam of light falls on a plane mirror, it will be reflected as a parallel beam of light, and you can be able to see your face there. On the other hand, we also want to look at, this is our wall, but then you cannot see the roughness of this wall. We need to zoom it via microscope, and you can be able to get that surface there, which you see. So realize that if a parallel beam of light falls onto that surface, this is our surface, it is reflected in different directions, as you see with the blue lines. So realize that that kind of reflection is termed as the diffuse reflection. But the question comes, does it also follow the law of reflection? As you ask yourself, because they fall and they're reflected in different directions. So this is where we want to answer. As the beam of light falls, the rough surface, the answer is it obeys the law of reflection, where we say the angle of incidence equals the angle of reflection. We want to look at this blue and red and then the yellow rays. If you look at the incident rays, the three rays here we are seeing, you realize that they do obey, but how do they obey the law of reflection? If you look at the reflected blue light and then look at the angles in which it makes with the normal, it basically obeys the law of reflection. When light falls on a rough surface, it will be reflected in different directions, as you see there. And if you look at the examples of irregular reflections, we have red surfaces, the wall, the books, and then the rest. As we saw with the summary, as we look at the aspect of a house, light falls through the windows, enters, and when it enters as a parallel beam, it falls on surfaces, and the reflection takes place through the surface it falls, the chairs, the carpet, and then the TV, and we shall be able to look at light inside. So in summary, when a parallel beam of light falls onto a smooth surface, the reflected rays are parallel, and this is called the regular reflection of light. When a parallel beam of light falls onto a rough surface, the reflected rays are not parallel. This one is called the irregular or diffuse reflection. Then finally, diffuse reflection allows light to travel in multiple directions, which allows us to see things that are not in the direct path of light. So that is basically a brief summary of the two types of reflection as discussed in that. As we move on, uh, We also want to look at some of the key terminologies. You have been hearing me talking about the incident ray, the reflected ray, the normal. We want to look at those terminologies which are used in reflection of light. So what are they? With our guiding diagram there, you see the incident ray, there's a dotted line, a normal ray, and then there is a reflected ray, and they are all coming at the same point. And then there is an angle which the incident ray makes with the normal, that one is called the angle of incidence. The reflected ray makes with the normal, that is the angle of reflection. So I want to discuss some of them. What are they? The incident ray, this one basically the light ray from the source that hits or falls on the reflecting surface. The other one is the point of incidence. M is a point on the reflecting surface where the incident ray falls. Our normal, that's an imaginary line that makes an angle of 90 degrees with the reflecting surface. And then we also have the reflected ray. Reflected ray there is the light ray which bounces off the reflecting surface. And then as we move on, we also have the angle of incidence, which is the angle between the incident ray and the normal. Then the angle of reflection, that's the angle between the reflected ray and the normal. And then also have the glancing angle. Now, the glancing angle, if you look at it, the glancing angle is the angle between the incident ray or the reflected ray and the reflecting surface. If you look at the surface, which is our plane mirror, and then you look at the gap between the incident ray and the incident ray and the reflecting surface, that is where the angle of the glancing angle falls. Now, that basically gives us a summary to the key terms, which those key terms will push us to discuss about the laws of reflection. In physics, we are governed by laws, and these laws help us to understand some phenomena properly. So under light also, as light falls on the surface, there are some laws which govern it, and as light bounces off. So I want to begin by looking at the first law. The first law talks about the incident ray, the reflected ray, and the normal. At the point of incidence, this one is very key. At the point of incidence, sorry if I can remove this one, at the point of incidence, that is very key. At the point of incidence, all lie in the same plane. And then our second law talks about the angle of incidence being equal to the angle of reflection. And those are the two laws which govern the aspect of reflection of light at plane surfaces. Now, interestingly, these laws of reflection, we cannot just believe them as they are. We need to understand how they come about. We need to verify these laws of reflection, and we need to know really that the angle of incidence equal to the angle of reflection. And then, do those three rays fall at the same point of incidence? So here, we're going to look at how do we verify these laws of reflection. It's going to be guided by the video. And before we go into the video, we want to look at what do we need to verify these laws of reflection. The first thing, of course, we need to know is we need to have is a polished surface, which is our plane mirror. We need a soft board. We need a protractor, of course, to help us measure the angles. We need the pencil. We need the ruler. We need the optical pins or the thumb pins. Optical pins, you can use them for producing the images and then the objects. The drawing pins, you use them for supporting the plain sheet of paper. And then, of course, you need a plain white sheet of paper. We need the mathematical set because there are things we need to pick from there. So in our next slide, we're basically going to look at a video explaining the above, how the above can be used stepwise. So in this slide, explaining how we can verify these laws of reflection. And here is a video which has the items which we looked at in the past slide. We have the mirror, which is attached to a piece of wood to support it, as you see there, plain mirror. And we have a ruler, pencil, pen, and we have the optical pins. That is our surface. We're going to support this plain mirror with the two thumb pins. Those are the blue ones you're seeing at the two edges, so that the plain sheet of paper does not fly away, as you see. And then the next step we're going to do is, after fixing a plain sheet of paper, is coming up with the mirror line. That is a point where the mirror will be falling or standing when we're carrying out the experiment. We call it the mirror line, where the reflection will take place. So this is our mirror line. We're shading it that way so that it represents the mirror. The other thing is, next is drawing the normal, a perpendicular line which bisects the mirror line, and that will be acting as our normal. After doing that, we do measurement of an angle. We want to come up with the incident ray, so we shall use our protractor, and our mirror line will act as a 90-degree line, and our perpendicular, that's where the 180-degree line will fall. So we shall measure an angle, say 50 degrees, shall dot it there, and then we bring our ruler, we draw a straight line there, and that will serve as our incident ray. After that, we replace the plane mirror onto it is a mirror line. The next step we do is fixing the first two pins, that is P1 and P2, which these two pins must be in a line, and images will be formed behind the mirror, as we saw earlier. And then we're also going to look at the image property. One of the key properties of the images, they are formed behind the mirror. And then the next thing is we fix the two other pins, that is P3 and P4. And while fixing them, they should be in line with the images of pin 1 and pin 2. They must be in a straight line. So we fix our first pin, that is P3, and then we also fix our second pin on this other side, that is P4. And that you fix that bearing in mind that you observe it using a single lens, that is a single eye. You fix it there, and then you can be able to view whether really they are in a straight line with the images of pin 1 and pin 2. As you see here, these are our pins 1 and 2. Their images are there, and these are pin 3 and pin 4. So we observe whether they're in a straight line. As you see, they are there. So the images of pin 1 and pin 2 are in a line with the pins P3 and P4. So that is what you should have done. Okay. After we remove the pin 3 and 4, we demarcate those points so that they are clear. We remove other pins, P1 and pin 2, and then the mirror as well. After that, we draw a line which is passing through the holes of pin 3 and pin 4, and that will be able to act as a reflected ray. After drawing that, the next step we do is you look at how the angles are, and then also how do you do that? We measure the angle of reflection, which has been made by the line drawn through holes of pin 3 and pin 4. So we measure it still from the normal to the ray. As you see, that is our line, and if you look at that angle from the normal to the ray, that angle there is also equivalent to 50 degrees. And this clearly shows to you that the angle of incidence is equal to the angle of reflection, which verifies the law of reflection. Then also the incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane, and that helps to verify the laws of reflection. In our next slide, we are going to talk about the image formation in plane mirrors, and what comes into your mind when you talk about image formation in plane mirrors. When a light ray from an object falls on a plane surface, it gets reflected according to the laws of reflection. This reflection creates an image that appears to be behind the mirror. So if you look at our our diagram here, we have a tree there which is standing in front of the plane mirror, and then this tree which is acting as our object, when observed from this other side of the mirror, you can be able to see it is image behind the mirror, like how we saw with in the video. And then when you observe, these rays will appear to be coming from a certain distance behind the mirror and as in front of the mirror. Then if you look at the distances, these are some of the properties you need. The distance between the object in front of the mirror and then the image behind the mirror, they are all the same. But this, what brings about that is the reflected rays. And these reflected rays obey the laws of reflection. As you see here, if you drop your normal here and then you measure those two angles, you should be able to get that they are the same. So what are some of the characteristics of the images formed by the plane mirror? As I hinted, some image is virtual, it's always formed behind the mirror. The image is upright, of course it's erect or standing. As you see, this tree also behind and in front. And then the other one is lateral inverted. The image is left is the object's right. The image is right is the object left. Then the size is the same as that of the object. How fat, how thin the image is, they are the same. The same story when you stand in front of the plane mirror in your dressing room. You should be able to see that there is no change in the image as compared to the object. Then the last one here is the image distance from the mirror is as the image distance from the mirror is the same as the object distance from the mirror. This distance is here where the image is standing from the mirror, then where the object is standing from the mirror. They are the same. As we finalize, we'll look at some terms, because these images as they are formed, virtual moves with a certain image, real moves with a certain image. So we want to summarize by look at some of the terms which you might encounter under images. One of them is a real image. What is a real image? It's basically formed when light rays actually meet at a point after reflection. The image is formed on the screen. That this one you clearly see the rays as you draw the principal rays as you draw them. They should be able to cross each other with solid lines, not like the dotted lines as we formed this image. The next one is a virtual image. The image formed when light rays appear to meet but do not actually meet apparent intersection of light rays. The image can't be formed on the screen. The typical example of that image is the one we see in plane mirrors. Then the last terminology is lateral inversion, is when the image appears flipped sideways, the left to the right in the mirror. And this is exactly what happens if we stand in the mirror and then we raise our right hand. What will be shown in the mirror is the left hand. That is what we term as lateral inversion. So that is basically where we're ending for this part of the slides. We're looking at this today. So in our next meeting, shall be able to continue from there. But for now, you can go on to read through this, learn more, watch through the videos, check on my YouTube channel, and be able to subscribe and comment where necessary. Thank you.